Hello, dear students. Let's see this question of IIT-JEE 1997. It's question of rigid body dynamics. The question states a uniform disk of mass m and radius r is projected horizontally with velocity v naught on a rough horizontal floor so that it starts off with a purely sliding motion at t is equal to 0. After t naught seconds, it acquires a purely rolling motion as shown in the figure. So we have to find two things. Number one, velocity of the center mass of the disk at time t naught, and assuming the coefficient of friction to be mu, calculate t naught. Also calculate the work done by the frictional force as a function of time and total work done by it over a time t much longer than t naught. So this is the situation given in the question. This is a rolling body disk rolling on a fixed platform. Initially, the velocity of center mass was v naught, and that was the overall velocity. It has only the translational motion, no angular velocity. So it means the point in contact of disk with the ground has also velocity v naught in the direction of motion, as it is doing a translational motion. So all points of the disk have the same velocity. And obviously the ground is at rest, so there is a slipping between point of contact of disk with the ground, and it is a forward slipping, so there will be a kinetic friction acting in the backward direction. So let me draw the FBD. There will be weight mg and normal upward direction, both will be equal and opposite. So normal reaction will equal to be n is equal to mg. So kinetic friction will be mu into n, that will be mu into mg, opposite to the direction of the motion of the center mass in the backward direction. So I am showing only the kinetic friction because mg and normal have no role in providing acceleration of the center mass as well as torque. So this is the kinetic friction, which is mu mg. And as a result of this kinetic friction, which is the net force, the center of mass will have an acceleration in the direction of net force, i.e. in the backward direction. And this acceleration will be A is equal to F net by M. So F net is mu mg divided by M will be mu g. So mu g is the acceleration of the center of mass in the backward direction. So this acceleration will serve as a retardation because it is opposite to direction of velocity of center mass. And this Fk will also provide some torque in the clockwise sense, so that will impart some angular acceleration to the disk like this. So to calculate angular acceleration, I am using equation I about center of mass alpha is equal to torque about center of mass. And I about center of mass is mr square by 2, and this is alpha. Torque is mu mg r. Simplifying this, we will get alpha is equal to mu g by r, and there will be twice here. So we've got the acceleration of the center mass and also the angular acceleration of this rigid body disk. So what will be effect of A and alpha? The effect of A will be after time t, this body will have some different velocity v, and also it will acquire some angular velocity omega. So at time t, v is equal to, we will write u plus at. Initial velocity is the v naught. Acceleration is actually minus a because it is retardation. So I will write in place of acceleration minus mu g and t. So this is the velocity at time t. For the angular velocity, I am using omega is equal to omega naught plus alpha t. Initial angular velocity was 0. And alpha we have just got, so omega will become twice mu g t by r. And then there will come a moment, say at t is equal to t naught, this body will start doing pure rolling. Pure rolling means it will doing start rolling without slipping, and when that happens, the velocity will match to angular velocity. So velocity will be r times of the angular velocity. So at t is equal to t naught, pure rolling starts. So then v dash will become r omega dash, and we've got v as a function of time. Just I have to put in place of t naught, we'll get the v dash. So v dash will be v naught minus mu g t naught, and similarly omega dash is the omega at t is equal to t naught the moment the pure rolling starts. So that will be twice mu g by r t naught. This r gets cancelled. So v naught and this mu g t naught will go to that side, will become thrice mu g t naught. So we get the time t naught when the pure rolling start, that will be v naught by 3 mu g. And that is one of the answers that was asked. And then the velocity of center mass for that thing, I'll again put the v dash. That v dash was v naught minus mu g t naught, and t naught is the, in fact, mu g t naught is v naught by 3. So this is a v naught minus v naught by 3. So that would be 2 v naught by 3. Now we have also find the work done by the frictional force as a function of time, and the total work done by it over a time t much longer than t naught. So first I'll find the work done by the kinetic friction before body starts doing pure rolling. So this at t is equal to t naught, pure rolling starts, and before that this was the expression for the velocity and the angular velocity. So in a time interval between t is equal to 0 to t is equal to t less than t naught, I want to apply work energy theorem. So applying work energy theorem. So work energy theorem says work done by all is equal to change in kinetic energy. The forces on this disk are weight, normal, and the kinetic friction. Weight, normal are doing no work. So the only work is done by the kinetic friction. So work done by the kinetic friction is equal to delta K. That is a final kinetic energy minus initial kinetic energy. Finally, if at time t the body is doing now the CTRM, in the CTRM the kinetic energy is a sum of two parts, translational and rotational. So rotational kinetic energy at time t is half ICM. ICM is the mr square by 2 into omega square, and this is the omega. So omega square means twice mu g t by r and then whole square. This is the rotational kinetic energy at time t. And the translational kinetic energy is a half mv square, and the v is this v naught minus mu gt, v naught minus mu gt, and then whole square. So this whole thing is the total kinetic energy at time t, and the initial kinetic energy was purely translation, and that was half mv naught square. So now let me simplify all this thing. So we can see that in all the three parts we have m by 2 common. So I'm taking m by 2 common, and here this r square and this r, and because that is whole square, will get cancelled. So I'll remain with that will be 2 mu square g square t square. From the second term I'll get v naught square plus mu square g square t square and minus 2 v naught mu gt, and the last term is minus v naught square. So this v naught square, this v naught square gets cancelled. So we get work done by the friction is equal to m by 2 3 mu square g square t square minus 2 v naught mu gt, and I want to write it because this work is going to be negative. Work done by kinetic friction is always negative uh, on one's body. So minus m by 2 twice v naught mu gt minus 3 mu square g square t square. So let me go to the next page. So we've got, let me write this friction work done as again minus m by 2 v naught mu gt minus 3 mu square g square t square. 3 mu square g square t square. This is the work done for interval t less than t naught, and I can include the equality sign also. So what is the work done till the body start doing pure rolling? So for interval t is equal to 0 to t is equal to t naught, in this interval, the total work done, let me call that work done to be some w naught, and here I have to just put the value of t naught, and t naught we had calculated to be v naught by 3 mu g. So 2 v naught mu g, v naught by 3 mu g, and here 3 mu square g square, and v naught square by, that will be 9 mu square g square, and further simplifying, that will be m by 2 mu g gets cancelled, that will be 2 by 3 v naught square, and that will be 1 by 3 v naught square. So overall, this work done w naught will be minus m by 6 m is already there, v naught square. So now let me summarize the everything. So work done by friction in a general time t. If t is less than t naught, that work done is this. If t is greater than t naught, so at time t naught, rolling, pure rolling will starts, and once the body start doing pure rolling, there will not be any friction. So whatever work has been done till time t naught, that will the work done for a long interval of time. So if uh, t is greater than equal to t naught, then I will say work done by the friction is just w naught, and which is minus 1 by 6 mv naught square, and that is our answer. Thank you.